Okay, so here's the PDF for Module 3. So number 1, we're just asked to find the domain and range and then represent it as a table, a mapping, and a graph. So domain would just be your x values, so that would be -5, -4, -2, 0, and 1. So remember, your domain is always just your x values, whereas your range would be your y values, so that would be 4, -1, 1, 4, and 3. Put it in a table, it would be -5, -4, -2, 0, 1, and then 4, -1, 1, 4, 3. So when we're mapping it, usually we like going from least to greatest, so our smallest domain value would be -5, then it would be -4, then -2, 0, then 1, and our smallest range value would be -1, then it would be 1, then it would be 3, then it would be 4. We have two 4s, but remember when we're mapping, we don't repeat, we just write 4 once. And what we'll do is we'll just connect it with 2 arrows as we're connecting our domain with our range. Okay, so your domain, you'd have -5, 4, you'd have -4, -1, you'd have -2, 1, you'd have 0, 4, and you'd have 1, 3. So you see how there's 2 arrows that are going down to 4. That's it. And then to graph it, so we'd have -5, 4, which would be right here. I'm sorry, right here. We'd have -4, -1, which would be right here. We'd have -2, oh, no, that would not be right there, I'm sorry. -4, -1 would be right here. We'd have -2, 1, which would be right here. We'd have 0, 4, which would be right here, and we'd have 1, 3, which would be right here. Remember, domain are your x values, so what are your x values here? It would be -3, -1, 0, -3, and 2. And what would your range be? That would be -4, 2, 0, 5, and 4. So in our table, we have -3, -1, 0, -3, and 2 for our x values, and then our y, our range, would be -4, 2, 0, 5, and 4. So for mapping this, our domain would be -3. We'd have 2 -3s, but we'll just put one of them. We're not going to repeat it. We'll just use 2 arrows. Then we'd have -1, 0, and 2. Then we have -4, 0, 2, 4, and 5. So -3 goes with -4, -1 goes with 2, 0 goes with 0, -3 goes also with 5, and 2 goes with 4. Then graphing it on the coordinate plane, we would have -3, -4, which would be right here. Then we would have -1, 2, which would be right here. Origin 0, 0. And we have -3, 5, which would be right here. And then we'd have 2, 4, which would be right here. So remember, for domain, we're going to want to go left to right using a pencil, or in this case, I'm using a lightsaber. So if we're going from left to right for domain, I don't touch anything over here. I don't touch anything until I get to x equals -3. Okay, and then from there, I keep touching all the way towards positive infinity. So what would my domain be? It would be x is greater than or equal to -3. My range, so if I have this line here and I go from down to up, why isn't it letting me do it? Okay, so it would be all reals. I mean, it might not look like it's all reals because it looks like you're not touching anything here, but remember, this line is going to keep on moving forever and ever and ever gradually in that direction. So it's actually going to be all reals. Same with this. Okay, it's going to be all reals for range. So for domain, we're going to go left to right. I'll get my lightsaber again. So if I have my lightsaber here going from left to right, it looks like our domain is going to be all reals. So that would be your domain for this function here. And then looking at range, we're going down. Why is it taking that with me? Whatever. So from bottom to top, it looks like we don't touch any values until we get to y equals -2. And we keep touching values until y equals 2. So it looks like it's between -2 and 2. Okay, so that'll be a compound inequality. That will look like this. Y is greater than or equal to -2, and y is less than or equal to 2 would be our range. So so there's a line, diagonal line. Remember, anytime you have these, I told you in class, your domain and your range are going to both be all reals. So here, if I get my lightsaber and I look for my domain, so I don't touch anything until I get to x equals 0, and I keep touching until I get to x equals 4. So this is going to be compound inequality with 0 and 4, x in the middle. So x is going to be greater than or equal to 0 or less than or equal to 4. For range, start from bottom to top. I don't touch anything until I get to -2, and I keep touching until I get to +2. So it would be -2 is less than or equal to y, which is less than or equal to +2, and that would be your range. We did an example like this in class, so hopefully you realize, even though this isn't a line, the domain and the range are going to be all reals for number 7. Number 8, excuse me. So if we get our lightsaber for number 8, you go from left to right. Looks like my domain is going to be all reals, because remember, this line actually keeps on, it's going to keep on going forever and ever. More gradual than when I drew it, but it is going to keep on going forever and ever, and it is going to encompass all of our x values. So your domain is actually going to be all reals, whereas if we get that line, where did the line go? I guess I have to make another one. And we go from bottom to the top. It doesn't look like we get any range values until we hit a y equals -2, and from there it's everything. So your range is going to be y is greater than or equal to -2. Get my lightsaber out again, and if we're looking for domain, it looks like we don't touch anything until we get to -2, and then we keep touching things until we get to 2. So your domain is going to be between -2 and 2. And for y, if we get our line here, and it looks like we don't touch anything until we get to -3, and we keep touching until we get to +3. So your range is going to be between -3 and 3. Here I won't bother to get my lightsaber out. It's pretty evident that your domain is going to be all reals for this one. And what is your range going to be? If we get our line, we don't start touching y value until we get to -1, then we keep touching until we get to 1. So your range is going to be between -1 and 1 for your y values. Is number 11 a function? Well, do any of the x's repeat? Look at our x's, look at our domain values, -2, 2, 3, 4, and 5. None of the x values repeat, so yes, this would be a function. Number 13, do any of our x values repeat? Yes, they do. We have a -3 here and a -3 here. So no, this would not be our function. Our domain cannot repeat. There must be exactly one output for each domain value. That is not a function. Okay. 14. Let's see, do our x's repeat? Yes, they do. So is this a function? No. 15, do our x's repeat? Yes, we have 2 arrows coming out of 6, so no, this would not be a function. 16 is a graph, so we would do the vertical line test. I'll use a lightsaber instead of a vertical line. And if I have a lightsaber here, do I touch more than one point at any time on this graph? No, I do not. So because of the vertical line test, we know that yes, this is a function. 17, vertical line test. Well, right here I'm touching 2 points. So right away that tells me that no, this is not a function. 18 vertical line tests. I never touch more than 1 point. So yes, this would be a function. And last, 19 vertical line tests. Get my lightsaber out. And yes, I do touch more than 1 point at multiple spots. So no, this would not be a function. That's it. This is going to be your test tomorrow, or your quiz tomorrow. I hope it seems pretty easy. I will see you tomorrow. Make sure you study.